Hi, so I'm back in the ILC JupyterHub, the workshop server we have set up, and today I want to show you some importing and exporting functions in the JupyterHub as well as within R. And so I have a notebook open here I'm going to use for the demo. And the first thing I would suggest doing is to always, when you start a new data analysis project, to set up a directory structure to organize that analysis. And one way you can do this is to create a project folder in your shared user directory and divide that up how you like to work best. In this example, I have set up a notebook, a figures, and a data directory. And those are the files that I'm going to be going over import and export functions in this demonstration. And so if you go to your start, you can double click into the shared directory and then on workshop. And most people have already set up a directory with their user ID. Mine is BFE4. And I already have some of these tests in here, but what you would do is control click or right click and set up a new folder. I'm gonna have to go through and delete all of these. And that would be with your project name, and then double click in there and you can set up a data file, a figure file, and a notebooks file. Okay. And then once you have that set up, go ahead and double click in your notebooks file, and you can control click or right click, and we're going to create a new notebook. And in this workshop, we're always using R because we're teaching the coding in R. So you can hit the R kernel and hit select. And then you will want to rename this. You can call it my project analysis. Okay. I already have my notebook set up, so I'm going to get rid of this. And one thing to note, and that can be confusing sometimes working in JupyterHub, is the working directory when you start using R within your notebook is automatically going to default to the path where you created your notebook. And so here, for example, if you create your notebook in a notebook folder within your shared user my project directory, your working directory is going to default to this path. If you're always just using absolute paths, then this doesn't matter so much, but if you're using relative paths, you're going to want to make sure that you know where your working directory is. And so I'm going to go ahead and just go in here, which I have all set up, and we can start by importing data. Today I'm going to go over a simple case of if you are importing data off of your local computer and you're bringing it into the hub so that you can do some analysis on it. What you can do is double click into your data and then a simple drag and drop. So from your computer, you would select in your Finder window, you would select your file and just drag it over just like this. So I am going to drag over a CSV file I've named Cassava Test. And if it's a small file, it will upload very quickly, and if you have reasonable internet speed. If it's a really large file, we are going to show in a future workshop how to directly access large data files on the server using different databases. So for example, in this case, you'll see that this file was downloaded from Cassava Base. And so in the future, we'll show you how to access data from something like BMS or Gigwa or Breedbase without having to download those really large data sets first, which can take a lot of time, and sometimes if you don't have good internet, it can also just be impossible to do. And so now that I have my data, I am going to create a variable for that path. So I'm going to call it Cassava path, and I'm going to give the path to that CSV file. And so I have it in the shared folder, workshop, my user ID, my project, data, and then this last bit here is the name of that file. I also put in here with the pound key a couple comments about the data. If this was a real project, instead of just a demonstration, I'd probably have an entire section that gives some background and metadata on the file. But since this is a demo, I'm just putting when I downloaded it, the date, where I downloaded it from, and just some very simple background about the study. So I'm going to run that. Now that variable's loaded. So now let's take a look at the data. And so I'm going to call this Cassava test. And I'm going to use the read dlim function that Brandon reviewed. And the path and the file with the path is called Cassava path. That's what I created this variable here for. I'm telling it how it's separated with a comma. I'm telling it that I do have a header. So I'm saying head equals true. And then this here is just saying to skip the first 3 rows. And I'm doing this because there's some notation on the top of this file that I just want to skip. So the header doesn't start until row 4. So we're going to skip the first 3 rows, go to the header, and then go to the data. And so I'm going to take a look at the top part of this table. I'm going to look at the dimensions, and I want to look at the column names. Okay, so here's my table. And you can see how it started directly with the header. And then I have, it's followed by all the columns, all the rows. The dimensions are 20 rows by 45 columns. And then these are all of my column names. And so I like putting the column names because then if I want to use that name in some code, I can just simply come here and copy and paste that. Especially for a table when you have a lot of columns, it can be hard to scroll all the way through that table to look at all your names. Okay, now I'm going to just filter this data a little bit. And so I'm going to load the packages, the R packages, which I'm going to use. These were reviewed also by Brandon, so this is going to be the dplyr package to do the filtering, and I'm also using this magritter package so I can use the piping notation. So these are already installed, I just need to load them, and it's going to create some output and some notation. This is just the masking where there's repetitive objects in the packages. Brandon went over that as well. I want to keep that there, but I'm just gonna hit this bar so that it's hidden. And so you can hide output, especially if it's really long or not really relevant at the moment. You can always hide it and click on these 3 dots when you want to see it again. Okay, so now that we have the data loaded, we have the packages loaded, I'm going to create a new table called Cassava test subset. And that's going to be created by taking the original table and piping it through with this piping function, piping it through the select function. So select, and I'm going to select all the columns starting with germplasm dbid to this stem diameter measurement. The reason I'm doing this is because in this case, this data file has a lot of meta file mixed in with the data, and I personally like to keep them somewhat separate. And so I'm going to filter out that metadata. And so I'm going to run head and dim again so we can look at what this subset looks like. And you can see it's a still pretty wide table, but much cleaner. And so now same number of rows, which I always like to look at that when I'm filtering as a check, but we have fewer columns. Okay, so now to the exporting part. We learned how to import data. Now how do you export data? So say I want to keep this filtered data table that I created. So I can save that as a file using R. So I'm going to create a variable for the new file name. I'm going to save this in the same exact place where I have the original file, but I'm going to save it with a new name. In this case, I'm going to use the original file name, but then I'm going to say clean, and I'm going to write the date, and you always want to also write your extension. I'm going to keep using the CSV extension. Now you can just export your data to that file name into that path, say write.csv, and then use your cassava test subset. That's the name of the variable we want to use from R to save. And then this is going to be what we save it as. So the path and the file name from here. Okay, so let's go ahead and run this one. And then we can run this to export your data. So I'm going to go, oh, is that it? No, it might take a second. Here we go. So you can see that just loaded, cassava test clean with the date. And so benefits of editing and saving data in R within your Jupyter notebook. So in this example, we now have saved the original file, which is unedited. That's this one. So no changes have been made to that. And then we have the new edited file. That's what this one is. And all the code in this Jupyter notebook that was used to modify that original file saved for both yourself and for others in case it needs to be repeated or just reviewed. You can also download the file onto your local computer alongside the original. And so you just right click or control click on the file name and then hit download. This is a good idea because it acts as a backup. So it's always great to have at least one backup of your data, and you never know if something's going to happen to a server where you may lose your data. You want to know that you also have a backup of that on your own computer. So now let's go over figures. So this is, if you're using R to create a figure, how you could then, I'm going to just remove something. I'll add it back in a second. How you can download that as a file on the JupyterHub and then on your own local computer. And so unlike with the data table we just saw, you need to tell R ahead of time that you want to export your figure as a file. And so I'll show you what I mean by that. But for our data table, we basically just did what we would normally do. And then when we're done, we just exported it. Here we're going to tell R that we want to save it as a file. Then we're going to run our function to create the figure. Then we're going to tell R that we are done. And it's going to print that to a new file. So first, like in every other example, I'm going to create a variable for my figure file. And so I'm going to direct R to save my figure with this title. So I'm going to call it hist cassava test because I'm going to create a histogram, and with the extension JPG because I'm going to save it as a JPEG. And then this is where I want it to be saved. So it's in my project directory in the figures folder. And there's other formats available besides JPEG. I put just a couple of some of the most commonly used here. So PDF and PNG. And so if those are what you would use, you would just substitute this function with one of these other ones. And then you make your figure. And we're going to make a histogram using the hist function. And the last step will be to signal the end of the code for your figure, which will create the figure. And this is using the dev off function to mark the end of your code. So when you put those three things together, let me run this so it saves the variable. When you put these three things together, so we're telling R, okay, I want a JPEG and I want to save it to this path with this name. Then this is my code to create the histogram. So what I'm doing is I'm using the hist function. I am using the data that I filtered, so cassava test subset. And this is the column name for the column that I want to print the histogram of. My title, my main title, the title of my x-axis, the title of my y-axis, and then this breaks tells R the size of my bins in the histogram, and you can alter this depending on what your data looks like. And then that third step is to mark the completion of my code. And so you just run that, and then you get a message like this. And so if I navigate to my figures, you can see that I have saved a figure, and I can double click on that to look at it. I also recommend, and this is what I just deleted though, that I like to be able to see the output of my code in my notebook. And so I can do that just by copying and pasting just that histogram function. And a lot of times it makes sense that you would do this first before deciding you want to print it, because it's easier to make edits just looking at the results of the histogram right in your notebook rather than keeping and saving these files. And then just like with the data, we can right click or control click on this and download it to our own machine as a backup. Okay, so the last part I'm going to go over is what we can do with our notebooks. And so for your own documentation, what I like to do is if I'm finished with the analysis for a project or for a day for a notebook, what I like to do is to then save that notebook in a format that preserves that documentation. And by that I mean it can no longer be edited, either on purpose or by mistake, or in a different or to save it to present your analysis to someone. And so to do this, let me go to my notebook here, which I actually have saved here. I call it 07 importing exporting demo, and you can see it as the IPYNB extension because it's a notebook. I'm going to delete this. Okay, so to export it as a different format, you would click on the notebook you want, go up to File, and then in that toolbar, that drop down that comes up, go to Save and Export Notebook As, and you have these different options. I would recommend you to use HTML or PDF. So here I'm going to do PDF. And we see a new window popped open, and it's basically just downloading a PDF to my computer. And what I'll do just to show you what happened is I'm going to upload that now. And so now you can see I have a PDF version. I'm going to rename it to get rid of, I've downloaded it a couple times for this demo. So I have the notebook version, and alongside of it I have the PDF. And what I would do is normally date that as well when I save the PDF. And then you can, like all these, you can download like your notebook onto your computer when you're done too. So you can download your notebook with the PDF alongside of it. Okay, so now what about sharing notebooks? So just some general tips is when using other people's notebooks in the shared directory, or when providing your notebook, it is important to preserve the original notebook. And so here are some general tips. When using someone else's notebook, make a copy of their notebook and then put that copy of the notebook in your own directory. Okay, and to do this, you can use a copy and paste function in the drop-down menu. So for example, if I wanted to use this notebook, I could copy it, and then you would simply go to this blank area and paste it. And you can see I just created now a notebook from that original named copy. And so now this is my own version of the notebook, and I can make changes to it and run the code and execute it without changing that original. And so what you might want to do is use someone else's code and then change the path to the data and run that code on your own data. Okay, and that would prevent you from kind of editing or messing up someone else's documentation and notebook. And then you could just simply save that in your own folder. Discard. So I'm going to delete that because I'm not really going to do that. If you find that you have altered someone's notebook by mistake, just don't save it. When the pop-up comes up to save it, say discard changes. And that happens quite frequently because sometimes you might have multiple notebooks open. You might have someone else's notebook open and you might just be copying a section of code out of it and forget which notebook you're in and start editing the wrong version. And if that happens, just discard your changes and it won't be a big deal because nothing will have changed. When working in an environment like these shared folders where others have access to your notebooks, be aware that other people can use your notebook and use your code, which is a great thing, but that it comes at a risk that your notebook might be edited by mistake. So what you can do is you can either work off a private directory. So if you go back to the start and you create a folder here, this is not going to be shared. This will be private to you. And you can work here, and when you're ready to share your notebook, put it in the shared folder. Or what you can do is just always keep a version of your notebook downloaded onto your own computer so that if someone makes a change, you have a backup version. In future workshop discussions, we're going to go over using version control in JupyterHub, like Git, and if you're familiar with Git, so that you can always revert to a previous version of your notebook if necessary. And so that is it for this demonstration. I'll show you that there is also a PDF of the demo and some exercises in the breakout room instructions folder, and they'll also be uploaded onto the website for this workshop. And so you can go through those exercises and have access to the PDF. Okay, thank you.